All right, so here we're going to look at a few more linear models as well as talk about some business applications involving cost, revenue, and profit. So this first one, I'm actually going to take out part of the question here. So at the end, we say find a linear model for the value. That's all we're going to do here. We actually didn't need this much space, but we're skipping horizontal intercept and domain and range. We're not doing that. Okay. So with that, we have a company purchased $120,000 in new office equipment. So we have new office equipment, cost $120,000. They expect the value to depreciate. So depreciate means to decrease. By, I have it down there, decrease by $16,000 per year. So we're seeing a decrease of $16,000 per year. Or another way to write that would be 16,000 and then having the units to the right, so it's like dollar per year. It's like $1 over years. Because then what this can help us do is set up, so dollars is going to be our output for the equation, and the year is going to be the input. So imagine this will work as input an amount of time, and then we can have an idea of like what's the value of this office equipment. So we're going to need two variables. So we're going to have a variable for representing the value of the office equipment. So let's go ahead and use V for value. So the value of equipment. And then T is going to represent the amount of time in years. So the number of years that have passed. Okay, so the value of this equipment is going to start at $120,000, and then we're going to be taking $16,000 away from that each year. So that behavior right there is the description of a linear model, because we have this initial value and then this variable cost, variable value, I guess it would be in this case, of how that value is changing year to year. So calculating value for our output, we have V equals, I'm going to go ahead and write our initial value first. So we're starting at $120,000. And then we're decreasing, so my slope is going to be negative, and it's going to be 16,000. And then we need to multiply that value by our input variable, t. So again, our linear equation can have two forms. It could either be y equals mx plus b, or you could write it as y equals b plus mx. But the idea is that b is some initial value, and then m is our rate of change, or a variable value. And then it's going to be positive when we're increasing, negative when we're decreasing. So you can imagine plugging in some values for t here. So like if we were at year 0, the value is $120,000. After 1 year passes, we have $120,000 minus 16,000. If 2 years has passed, then we take away 16,000 twice. 3 years have passed 3 times, so on and so forth. So initial value, and then we have our slope, and then we just need to multiply our slope by our input variable. All right, let's go to a business application dealing with total cost, revenue, and profit. So with businesses, what they're going to do is, in terms of, they'll have cost of production of something. They can bring in money from that item that they're selling. And then we're interested in profit. How much money are they actually making? So with the equations that we're going to look at, total cost is going to come through as a linear function. So total cost, which is actually kind of what we did here. This was more based on value. We definitely did this in our very first example here, way back when, with this was a calculation of cost where we have some initial cost and then we have this cost being added on per item. That's exactly what we're going to see here. So some fixed cost and then a variable cost. So what I'm going to write here is that total cost TC is equal to taking some fixed cost plus some variable cost that's going to multiply with our input variable, which is going to represent the quantity of the item that we're working with. So we're going to use Q. So we're going to see two variables come up here. Q is for quantity and P is for price when we get there. So this is just our slope-intercept form. Like there's our B plus MX essentially, but we're focusing on the specific model with businesses where that total cost that they're incurring, they have some fixed cost, and then they're going to have a cost per item, just in terms of production. It costs to make that item in terms of materials, labor, things like that. Okay, revenue, which is the equivalent, it's the sales that they're making from the item. So whatever they're making, they're going to sell a certain quantity at a certain price. So the total sales that they're bringing in, or this revenue, is going to come from taking that price of the item that they set times the quantity. So if we are selling phones for $1,000 a piece, if we sell 5 phones, we would have 5 times 1,000. Yeah, we made $5,000. Awesome. So revenue is just the money that's brought in by selling a certain amount of items. Profit takes into account both of these things, because as we're operating as a company, sure, we bring in that money, but we have these costs that are being incurred too. Like I said, those fixed costs, those things that we just have to pay for no matter what, like the rent or mortgage on a building and things like that. And then variable costs that are going to change based on the amount of items that we produce, like materials and things like that. So revenue doesn't think about cost at all. This is all just about the money that is brought in. But then what we need to do is think about, well, we need to pay for these costs. So this is where profit comes in. So profit is equal to, if we take that revenue, so that money that's brought in, but then take out those total costs that were incurred. So seeing that difference, we can actually see the profit that we're making. So it's like the actual money that we're making. So if that difference is positive, then we're working at a profit and we're making money. If we take that difference and it comes out negative, which is very possible, that means we're operating at a loss. We're actually losing money. Our costs are more than the money that we're bringing in with revenue. Okay, so let's try this out with a word problem. We basically have 3 equations here. The total cost is going to come through with a linear equation like we've been practicing. Revenue is going to come from multiplying price and quantity. And then the profit is going to come from looking at the difference of those two. All right. So we have a tech startup is looking at developing and launching a new mobile app. Initial development of the app will cost $300,000. So I'm just going to make a note that we have this cost of $300,000. And they estimate marketing and support for each user will cost 50 cents. So we also have this cost of 50 cents per user. Okay. While the app will be free, so it's kind of talking about the price being equal to 0, they estimate they will be able to bring in $2 per user on average from in-app purchases. So really, even though it's marketed as free, the cost to the customer, so this price, is really $2 per user. On average from in-app purchases. Okay, the question is, how many users will the company need to break even? So, breaking even is an idea in business where the profits are zero. So typically, when companies get started, they're investing a lot of money into their product, they're trying to get word of mouth going. So with that, they're not going to charge a high price right at the beginning. So typically at the beginning of a business, they're operating at a loss, meaning they have a really high total cost while revenue's low. But then as their business gets better and stronger, typically the revenue should start increasing up and getting better and better. And with that, we hope that revenue ends up catching up with our costs. And we'd love to get to this point. Like, ideally, we want to get to a point where we're making a profit, but there's going to be this transition stage of where profit is zero. So this idea of breaking even is where the total cost is exactly equal to the revenue. So the cost that we're incurring is exactly the same as the money that's being brought in, which in terms of profit means we're making a profit of zero. So what we're going to do for this scenario is we're going to create an equation for total cost. We're going to create an equation for revenue, and then we want to see where they equal each other. So in terms of cost, so I'm going to use TC for total cost equals, and we're going to have fixed cost plus some variable cost times our quantity. So the cost, there was this $300,000 fixed cost. So we're going to have that 300,000. And then plus there's a cost of 50 cents per user. So I'm going to go 0.5 times Q. So if we have one user, that adds 50 cents to our cost. 2 users, that's adding $1 to our cost, so on and so forth. Revenue is going to come from taking the price times the quantity. So how much money is being brought in? Well, we should be getting about $2 per user. So we're getting $2 times the quantity, where Q is really the number of users that are getting this app. Okay, so we want to see where is total cost equal to revenue. Well, total cost is the same thing as this 300,000 plus 0.5 Q. And we want to see where that equals revenue, which is equal to 2 times Q. And now we can solve for Q. So I'm going to subtract 0.5 Q from both sides. So I'll be left with 300,000 equals 1.5 Q. Divide both sides by 1.5, and that should be 200,000. So this is the number of users needed to break even. So what the company could do is, if they're working with these expected numbers, they're going to aim to get to 200,000 users, because that's when their profit's going to be zero. Then when they go beyond that number of users, if they get even more users, that's when they start making a profit. But typically when businesses get started, they'll look at this break-even point as a kind of goal to hit in order to make sure that revenue is matching their total costs.